Good afternoon, class. So at this point, we're looking at quadratic equations and inequalities, and that is on page, yes, whichever page you're on. Then, you guys had some homework, of course. The homework was on page 30. Nice. So yesterday we spoke about the maximum and the minimum and how we can extract that if it's written in the form of a into x minus p squared plus q, the relationship that the turning point has with that format of the equation, okay, or the expression. So we did exercise 2.5, which I had no problems with. You had to do 2.6, the even numbers, correct? Am I right? Huh? Yes, you had to do everything for today. Okay, nice. Nobody said thank you, but it's fine. It's a pleasure. So 2.6, any issues here? Let's talk about the problems in our lives. Yes, Michael. Sorry? So I go to number 14.
No. Copy is out there. Extend the state for number 14.
Number 14. You're going to explain what you did and I'll explain where and I'll try and pick up where you went wrong. Is that okay? Yeah. Nice. I like it if it works like that. So that you can learn where you went wrong and I can also pick up where you went wrong. So for you, I'll draw the graph as well. Okay. Special. You feel special? You say no. Now I feel bad. Bad I feel. There's no place here. I will go on the next page. Nope, that's grade 12 geometry. You guys are not there yet. You see the nice thing about this, no? Is the recordings. Next year, in your December holiday, you just start watching the videos. You don't have to do anything. Just watch it. A couple of videos beforehand. No? So when you come to class next year, and I'm still here, whoever is going to teach you in grade 12, no? And that person start explaining, then it's going to be for the second time you're hearing that same thing. You understand? It makes it easier. That is why some people feel like the tutor does more work than the teacher. It feels like it at times. No? So I do tuition as well. Then people say, no, they understand. It's not that. It is because they are hearing the same thing for the second time. That is why it feels like you understand more. Okay? And besides that, you know, paying extra now, you must have to listen. Otherwise your mommy give you hiding. No? You guys still get hiding? Yes, good. So that is why you guys are the best amongst us. No? You stop the hiding and then the problem starts. You see? But anyway, some people would differ. Or many would differ. You're also differing. Now one day when you have your own set of kids and then we talk again, okay? People! Your own set, yeah. Don't only have one, huh? Right, here we go. For each of the following, they ask you to write the expression in the form of a into x plus p whole squared plus q. Okay, that's number one. So in other words, that is completing of the square. Not so. Right, go for it, Michael. What are you going to do first?
I separate. Wait, no, sorry. You separate and you separate expressions.
Say factorize.
Oh.
Not O. Not separate. Factorize. Factorize. Not separate. No? You're talking about families and now you're talking about separations. Why are you like that? And then carry on.
Okay, and then x squared
Yeah.
minus negative 823
Yeah.
plus
plus 3. Absolutely correct. Not so. You ask yourself, what must be added here to complete the square root? Must be the same number I'm subtracting. Which is what in this case?
For mine, okay, I think this is where the mistake was. Mine was 64.9.
No. Well, how do we get this number? Yeah, it could be right. No, not 64. How do we get this number here? It's b times a half and it must be squared. So b times half is negative 8 over 3 times half squared. So it will be negative 4 over 3 squared. Which is basically positive 4 over 3 squared. Not so? And what is 4 over 3 squared? 16 over 9. And that was your mistake.
Yes, sir.
Okay. So what is this now to us? Not a trinomial. It's a perfect square trinomial. So you say negative 16 over 9 plus 3 is 27. It's going to give you a positive answer of what? Sorry?
Oh,
Put on your calculator, don't use your head.
37.
So 27.
30.
Can't be 37. You got negative 16. You see, that's what happens when you do these things in your head. 11 over 9. You understand? So many learners now, what they do is they forget to put a negative. So don't be like many of the learners. Okay? You was the other kind of girl. No? Very good? 11. Now what do we do? Now we multiply this. So that's going to give you negative 3 into x minus 4 over 3 squared plus, now minus 11 over 3. Understand, Michael? Okay. Then let's say determine the maximum or minimum value. Will this graph have a maximum or minimum? It's going to have a maximum. So this is going to be negative. So it's going to be a maximum. Where is the negative? Here. It's going to be a maximum value of 4 over 3 and negative 11 over 3. Not so. But what's the question? Determine the maximum minimum. So this will have a maximum value of negative 11 over 3. Okay? See, the question was, give the value for x for which the expression is the maximum minimum. So what is the value for x? X is equal to? Which is always the additive inverse of that. Okay, and she says he doesn't want me to draw the graph, so it's fine. But you guys understand? Okay, any other problems with 2.6? No. So now we're looking at practical application of finding maximum and minimum values. Practical application of finding maximum and minimum values. And this is on page 31. 30, still on 30. You guys ready? Alright. Let's do this. So practical application of finding maximum and minimum value. Example on page 30. A farmer plans to construct a rectangular enclosure for his sheep using 100 meters of fencing. So the idea is when you have 100 meters of fencing, okay, we would like to use the maximum fencing to get the maximum area. So when we use the fence, we try and we're going to, in practical terms, use everything. You understand? So the length of the fence, let's call it alpha now. The length of the fence is going to be 100 meters. Okay. You all okay with that? He makes use of an existing boundary wall. Okay, remember now he's using an existing boundary wall. Okay. As one of the sides of the rectangular enclosure. So let's say this is the wall. So a rectangular fence is going to be constructed in that manner. People, there's nothing wrong with the farmer in his head, so he will never put a part of the fence against it. So he's not going to fence against the wall. Would you guys want to fence it, or let him fence against the wall? No, it's not practical. Doesn't make sense. Not so? What he does is, when he fences, he goes against the wall, goes over as a length, and again the breadth. Alright? So 3 sides are fenced, and 1 side is wall basically. One side of the rectangular closure is wall. Calculate the dimensions. People, what's the dimensions? The word dimensions also means? The dimension is the sizes. You know? Calculate the dimensions of the rectangle so that you can get a maximum enclosed area. So you can get a maximum enclosed area. Now when we spoke about the quadratics, what do you notice? We had the maximum or minimum values, not so? And in which form did we need to get it in? In the form of ax squared plus b, a into x plus b all squared plus q. This is the format in which you must get it in, to then read the maximum or the minimum value. You guys understand? Alright. So let's go here. So let the breadth be x. Okay? So there we'll have an x and an x, not so? Okay? So what would the length be? This part here. See, I already used the alma. Okay, so I don't want to call it length. But how would we calculate that here? Let's call this y. Are you going to calculate that? Our first step is we must try and get y in terms of x. Okay. Let's give you notes here. So first thing, to get y in terms of x. What do we know? We know that x plus y plus x adds up to what? 100 meters. Okay. So you say y plus 2x is equal to 100. So what is the value of y in terms of x? 100 minus 2. In other words, this length here can be represented in terms of x. Why do I want one unknown only? Easier to work with. We complete the square. Remember when we completed the square? There was one unknown only in the sum. But here it was just an x. Not so? So the question is calculate the dimensions of the rectangle so that he can get a maximum enclosed area. How do you calculate the area of a rectangle? So it's going to be the area is equal to length times. What's the length of this piece? 100 minus 2x. What's the breadth? X. So now you're going to say 100 minus 2x multiplied by x. Okay? You multiply it out and then you complete the square. So do that for me quickly. Now pause the video at this point. Okay. So what is your length? 100 minus 2x times the breadth, which is x. So what I'm going to do is I'm going to multiply this out and write it in standard form. So negative 2x times x is negative 2x squared plus 100 times x is 100x. Okay. So if we're going to apply completing the square on this here, what will we get? Let's complete the square. Example on page 30. Okay. So what do we do? We take out negative 2 as a common factor. Okay, we always want the 1 in front of x squared. So we take out negative 2 as a common factor, what are we left with? X squared minus 50x. And that's it, not so. So what must we do now? We must add a number to complete the square with. We must subtract the same number. Okay. So what's the first number going to be? B times half. This is 50 times half, which is 25. And 25 squared is 625. So what do we get now? Perfect square trinomial. Not so? We get now a perfect square trinomial. So you get negative 2 into x minus 25 squared minus 625. You guys understand? Now multiply. So multiply negative 2 in. That will give us negative 2 into x minus 25 squared plus 2 times 625. So 1, 2, 1. So what does that mean to us? Put this in terms of the parabola. You would have had a turning point, a maximum value of 25 and 125. But what does that tell us? Tells us that the area, the maximum area, put your maximum area would be 1250 meters squared. And it will occur at a breadth of an x value of 25 meters. Okay? That's at which the maximum value occurs. Which means to say, people, if you choose any value here for x, let's choose a value. Let's put it to practice what happened here. Choose any value for x. 10. Okay, so you got 10. So this is now also 10. Not so. And what would the length be? 10 100 minus 2 times 10, which is 80. So the area of this is going to be 80 times 10, which is 800. Alright then? Your history book. Why is your history book out in this class?
I was checking for my maths book, sir.
Huh?
I was checking for my maths book.
In your history book?
No.
Your maths homework was in your history. Oh my word. Okay, check this one. Okay. Can you see the people? That comes out to be 800. Is 800 not less than 1250?
Not yes.
Okay. You all agree with that? Let's choose another number.
7.
Oh my word. Choose 20. Good, that's a very good choice, 20. Okay. Why? Because those numbers I can work in my head, otherwise I need your help. Right, so that's going to give you also 20. So this here is going to be 100 minus 2 times 20, which is 40, which is 60. So the area is going to be at 20 by 60. So it's 1200. That's close. Can you see that? And if you go closer and closer, approach closer and closer to 25, you will see the area gets larger and larger. At 25, it will be the largest possible it can be. So if I'm going to choose x to be 25, then it's going to be 25 times 50. Okay, which is then going to give you 1250. Does it make sense? So the largest possible area, given the conditions, is 1250. It will occur at a breadth value or an x value of 25 and a corresponding y value of 50. So the length is going to be 50 and the breadth is going to be 25. Did we answer the question? What is the question? The question says calculate the dimensions. So these are your dimensions. The length is 50 and the breadth is 25, so that you can enclose a maximum area. So this is the answer they wanted. Okay? Okay, any confusion here? Any questions? No? For homework, I'm not going to give you a lot of this to do. So every day we will look at the homework I gave you, okay? For homework, I want you guys to do 2.7, number 1. Okay, 1 and 2. We'll just do number 1. Just number 1. Yes, Michael?
What's happening outside of this next week?
Everything up until here. Okay. So you're going to get one of these. Practical applications, okay? Next heading, quadratic equations. Quadratic equations. Yes? So this won't be covered in. But I'm not going to stop here because we are taking it slow already. Okay. Can you feel the pace is slower than?
Yes.
Yes. Yes? Why? So you're now advocating for the maths lit learners. Nice.
No.
You see, if you're going to combine those classes, they can't fit in here. So until they can fit in here, or they can fit in by Mr. Kwababa, then we can do this one. No? So we're on page 32. You want to go to Mr. Kwababa's class? Huh? It's fine. I'll take the maths lit. Alright. So let's see if that's going to work. So now we're looking at quadratic equations, and this is on page 32. So here we are given what a quadratic equation is. A quadratic equation is one variable, or quadratic equations in one variable are equations that can be written in the form ax squared plus bx plus c. People, this is the standard form of a quadratic equation. Not so. Where a is a non-zero number, it can be any number other than 0. Because the highest power on x is 2, the equation will have two solutions. The solutions are also sometimes called roots of the equation. So later on when you see they ask you to calculate the roots, they are actually calculating the x values. Okay? You guys understand? We are told that the solutions may not be rational numbers. Now, rational numbers are nice numbers that can be written as fractions, okay, or whole numbers, which we then can convert to fractions and so on, okay. But the rational numbers are numbers that can be written as fractions, recurring numbers, or terminating decimal numbers, okay. If the solutions are rational numbers, then it is possible to solve the equation by factorization, okay. So if it can work out to that nice trinomial that we factorize normally, those values that we normally worked out, majority of the time we worked out, was rational numbers. Remember the product line we did in grade 10? Those are all rational solutions, okay? We are told to solve the equation by factorization where the factors have integer coefficients. Okay. The two solutions may also sometimes be equal to each other. Not so? And an example of that is a perfect square trinomial. Not so? The two roots are actually equal to each other. Or the two solutions are equal to each other. The solutions may be irrational numbers or could even be a non-real number. So later on we'll speak about roots or x values, where the solution you don't even have a solution to the equation, to a quadratic equation. Sometimes the solution can be rational, it can be irrational at times, or it can be non-real, non-existent, or no solution. You guys understand? So those are the three cases. So for now, we're still keeping it simple. We're solving quadratic equations by factorization. Okay. And this is on page 32. Solving equations, quadratic equation by factorization, page 32. So solve the quadratic equation. So what do we do here? X squared minus 5x plus 6 equals 0. So what do we do here? You stretch, yes. Nice. Then what do we do? If the question says solve the quadratic equation, what do we do? Factorize. So factorize quickly. Then you solve the equation. Whatever you learned last year still applies, no? Sorry. Alright, I take it you guys are finished? Yes? So let's factorize into what? The factors are 1 and 1, 1 and 6, 2 and 3. Do we add or subtract the factors? We add. So what are the factors? X minus 2, x minus 3. You all agree with that? Right, so what do we do now? X minus 2 is equal to 0 or? X minus 3 is equal to 0. So x equal to? Or x equal to? You all okay with that? Right. Let's look at example 2. Example 2 on page 33. There's the next one. Right, so what do we do here? Sorry? What do we do here? Square both sides. You all agree with that? No. Why would you square both sides? You take square root. Is that what you're saying? Square root. Okay, no problem. So it's square root both sides. So it's sorted. But here you got a bigger problem on the other side. Take that 4x. Why? Yes. And what type of equation is this? Quadratic equation. Not an O, it's a 0, no? Sometimes you get confused and you think it's an O. Okay. Now what do we do? Factorize the x. Okay, so do your thing. We got x as a common factor. What are we left with? X minus equals 0. Now what? X is equal to 0 or? X is equal to? Any of you confused? Not yet. Okay, good. Question 3. Sorry? You can say so. Why you feel like we're not challenging your mind yet enough? Okay. Tomorrow is another day. All right. I don't want to just skip through this because, okay. I don't want to skip through this because it's worth a couple of marks in an exam. Is number 3. There are three sums there. Example 3, 4 and 5. You can do all three. Sorry? Humbling. You're stuck. Oh, I thought you were saying the stuff is so easy and now it's humbling. Okay. So what must we do here? Product line. Factorize. You know how to do the product line. The factors of what? 2. Factors of 6. You remember that of last year? Yes? Okay. So the factors here is going to be 1 and 2. For 6 is 1 and 6, 2 and 3. If the factors doesn't work, what do we do? Swap it around. Not some one of the 6. You with me, Michael?
Yep.
So you know what to do from here. Okay. Then example 4, we first need to multiply that out. And then we bring the 10 over, then we factorize it. No? Same with number 5. I'm going to pause the video at this point. I'll give you a couple of minutes to sort out these 3 sums. And we'll be back. Okay, so with regards to the 3 sums, as we said, when we will be finding the product or the factors. So it's 2 times 2 is 4, 1 times 3 is 3, 4 minus 3 is 1. And that's what I want. Okay? So it's x and a 2, a 2x and a 3. So that's negative, so signs in the bracket, one must be positive, one must be negative, the bigger one must be positive. The big one takes the biggest product takes the sign of the middle term. So 2 times 2x is 4x, x times 3 is 3x. So this has to be positive. So the positive goes there, the negative goes there. Okay. So in other words, we've got x plus 2 is equal to 0, or 2x minus 3 is equal to 0. We set each factor equal to 0 by the factor rule, 0 factor rule. So x equal to negative 2, 2x is equal to 3 divided by 2, x is equal to 3 over 2. Okay. Let's look at the next one. This is also on page 33. What's wrong? Okay. So as we see in example 4, you must first multiply out to get rid of the bracket. For the 0 factor rule, it must be equal to 0. So let's multiply out and see what we get. So x times x is x squared, x times 2 is positive 2x, minus x minus 2 is equal to 10. We could have brought the 10 over one time, it would have been going to minus 10 equals 0. Again, the idea is to write it in the form of ax squared plus bx plus c, as indicated initially. Adding items is x squared plus x minus 12 is equal to 0. Again, this is a trinomial, so we're going to find the factors thereof. So it's going to be 1 and 1, 1 and 12, 2 and 6, 3 and 4. Do we add or subtract our factors? We subtract it. Okay? So 1 times 4 is 4, 1 times 3 is 3, 4 minus 3 is 1. So in the bracket goes 1 and a 3 and 1 and a 4. So it's a 1 and a 3, an x and a 3 and x and a 4. Since there's minus, 1 must be plus, 1 must be minus. So the bigger product must again be positive. It won't always be positive. Just in this case and the previous one was the same, but the bigger one has to be positive. So the 4 has to be positive. Now we don't put a positive there. It's going to go there and okay. So again the bigger product must be positive. So in other words, x minus 3 is equal to 0 or x plus 4 is equal to 0. So x equal to 3 or x equal to negative. Okay? And the last one, on page 34, example 5, it says solve for x, for 2x into x minus 1 plus 3 equals x minus 2 times x minus 4. So first things first, get rid of the brackets. So that's going to give us 2x squared minus 2x plus 3 equals x squared minus 4x minus 2x plus 8. Okay, it's quadratic equation, so I bring everything to one side. So it's going to be 2x squared minus 2x plus 3 minus x squared plus 4x plus 2x plus minus 8. Again, like terms, so that's going to give you x squared. Negative 2x minus 2x, negative 2x plus 2x cancels, give you a positive 4x. 3 minus 8 is negative 5 equals 0. Again, it's a trinomial in the form of ax squared plus bx plus c. So you must now factorize the trinomial. Okay? And of course, on your product line, it's 1 and 1, 1 and 5. So if we add or subtract our products, we subtract it again. Again, in this case, it will be x and 1, x and 5. The bigger product must take the sign of the middle term. Again, it's positive here. Again, that won't always be the case. So you got x minus 1 and x plus 5. So we say x minus 1 is equal to 0. So x is equal to 1. Or, that is for that factor, x plus 5 is equal to 0. So x is equal to negative 5. So for homework, I want you guys to do exercise 2.8 on page 34. You do the odd numbers only. Exercise 2.8 on page 34, the odd numbers only. Enjoy the rest of your day. Good afternoon.